What we're going to do on this one is we're just going to talk about the least degree of this polynomial. Now, I'm not going to actually find the polynomial because I don't have nice values for my x-intercepts. That's what we're going to do on the next example. But this one, we're just going to talk about the least degree. So one of the ways that you can do it is look at the x-intercepts. But I only have 2 x-intercepts, so that's not going to help me. So the next thing I can do is look at my turning points. So if I look at my turning points, I have a turning point right here. I have one right here. I have one right here. And I have one right here. The way that we define turning points is I'm coming in increasing and I leave decreasing. So I come in decreasing and leave increasing, and I come in increasing and leave decreasing. So turning points means my intervals of increasing and decreasing change. So those are true turning points. So I have 4 turning points. The least degree has to be what? Is it 5? So we know that if our polynomial is degree n, then n minus 1 is the maximum number of turning points. So I have 4 turning points, n minus 1, and that's why I have the degree 5 is the least degree. And I say least degree because I can always make it higher, right? I can always make it higher as long as the fact that my behavior matches that. So I can't make this a behavior, or I can't make this an even degree. Why can't I make this an even degree polynomial?
Because it's...
Yeah, so an even degree polynomial should be either up, up. So on the left-hand side, I should start with a positive infinity and end with a positive infinity on the right-hand side. Or I should start on the left-hand side and start with a negative infinity and end in a negative infinity on the right-hand side. So I know this has to be an odd-powered function. So any odd power function of at least 5 will work, but they want the least degree. The least degree is 5. Could 7 have worked? Sure, it could have worked. Could 9 have worked? Sure, 9 could have worked. Because when we're talking about the max number of turning points, it is the degree minus 1. That is the max number of turning points. I'm never guaranteed that number of turning points. It is the max number that I have. So if I look at, the reason I'm talking about this is, so if I look at this particular example, this is x to the 5th. This has no turning points. There's no turning points because the entire time I'm going along this graph, as I'm traveling along this graph, I'm increasing the entire time. I'm not decreasing. So it actually has no turning points. So I can have at most 4, but I'm not guaranteed 4. Does that make sense? Okay. So the next example here is they want us to build the polynomial given this information.
On that top one,
Mm-hmm.
how do you know that 5 is at least the degree?
So the least degree is 5. I could have had a degree 7 or 9 or 11 or any odd powered degree, but the least power I can have is 5. I can't have a power of 3 because I have too many turning points for a power of 3. So the least one is my number of turning points plus 1.
Oh, okay.
That's the least one I can have. So I can't have 3. 3 wouldn't work, and obviously 1 wouldn't because that's a line. So when they're asking for the least degree, that is the smallest degree. Then on this one, we want a polynomial of the least degree that is described by this information. The previous one, I didn't have nice x-intercepts. And not only did I have not nice x-intercepts, this right here, so let me erase part of this. This here, this turning point is below the x-axis. That means some of my zeros would be complex, and I don't know what they are. I don't know what they are because they're not crossing through the x-axis. Because they're not crossing through the x-axis, this is going to be way more difficult for me to determine what the polynomial is. So I wouldn't give you something like this because I don't have nice intersects. I don't have nice x-intercepts. I have x-intercepts here and here, right? I can find those. They're not nice numbers. They're not integer numbers when I say nice numbers. So I wouldn't give you this one. All I'd ask you is what is the least degree of it, but I wouldn't ask you to build the polynomial. Now, this one I'm going to ask you to build the polynomial because I have nice x-intercepts. And I don't have any turning points that are not around an x-intercept. So the first thing I do is I look at my graph. Each one of my tick marks represents 1. So I find my x-intercepts. My x-intercepts come from my zeros. So my x-intercept here happens to be -2. My x-intercept here happens to be +2, and my x-intercept here happens to be 3. So it is -2, 0, it is 2, 0, and it is 3, 0. So those are my x-intercepts. My zeros produce my x-intercepts if they're real numbers. If they're not real numbers, my zeros won't produce an x-intercept. So I know from here, this would have been x equals -2. This would have been x is equal to 2. And this one would have been x is equal to 3. Those would have been my zeros, yes. These are my zeros. So now what I have to do is find my factors that are associated to those zeros. My factors associated to those zeros is x plus 2. This one would have been x minus 2, and this one would have been x minus 3. Now I have to look at the behavior of those zeros at those intercepts. My behavior at x plus 2 is a passing like a line. So I know that the power on that is 1. My behavior at x minus 2, or in other words, at 2, 0, behaves like a line. And my last one also behaves like a line. So I know that their multiplicities are all 1. If I would have had a graph that, say, at my x-intercept it does this, say that my graph comes back up here and slides like that, then I would have had right there, because it's acting like a cube there, then I know that that 0 would have been a power of 3. If I would have had my graph would have came back up and it would have bounced, then I know the least degree on that one would have been a 2, because it's acting like a quadratic there. So that is the multiplicity. Because these are all passing like lines, if I were to zoom in, that looks like a line. If I zoom in on this one, way in on this one, that looks like a line. Zoom in on this one, that looks like a line. So they're passing like lines, so I know my multiplicities are all 1. Does that make sense?
Oh, they pass like lines, but when they like move, it just looks quadratic, even though that's just the connecting line.
Mm-hmm. That's just the connecting part of the graph. If that point right here, what you're asking about, if that would have been on the x-axis, then that would have been a multiplicity of 2. Okay. Because it's not on the x-axis, we're not even going to consider it right now. Okay. So what I have is I have this function now. I have f of x is equal to, I don't know what my leading coefficient is, so I just put a there as a placeholder. Then it's going to be x plus 2 multiplied by x minus 2 multiplied by x minus 3. I cannot make the assumption that my leading coefficient is 1. So I just put a as a placeholder. Once I put a as a placeholder, I'm going to choose another point on the graph so that I can figure out what a could be. So I'm going to choose any point. The best point to choose, however, is the y-intercept, provided the y-intercept is not 0, 0. If the y-intercept is 0, 0, you don't get to choose the y-intercept. Or if the y-intercept is not a nice number, I don't get to choose it. I'm going to choose any number that is a nice number. I could have chose this one, but I don't know exactly where that is, right? So I'm not going to choose that lower number. So I'm going to choose, in this case, the y-intercept, which is 1, 2, 3, 4, 5. So it is 0, 5. So I'm going to use that to figure out what a is. So I use, in this case, 0, 5, because it's on the graph, and I can't choose one of the x-intercepts, because it's going to give me 0 is equal to 0, which is cool, it's true, but it's not going to help us. So I use any other point. I have a nice y-intercept, so I'm going to use it. Now, what that tells me is this is f of x when we are evaluating at 0, right? So I get to replace this part with the 5. This part is going to go in wherever I see x. So if I put in 0, 5 comes out. So this is going to be equal to a 0 plus 2.
Are you sure it's 5?
I'll look again. 0 minus 2 and 0 minus 3. I'll go back and look. Because I am sketchy, you never know.
I was counting like, pretty sure that's 6.
So 1, 2, 3, 4, 5, 6. Yep, you're right. So by the magic of marker, look at that as a 6 now. So I'm going to make this a 6. I'm going to make this a 6. Okay, thank you for catching that.
Yeah.
Okay. So now I'm going to solve for a, because the only thing that I don't know is a. So basically what I have is I have 6 is equal to a. 0 plus 2 is 2. 0 minus 2 is negative 2. And 0 minus 3 is negative 3. So I've got 6 is equal to a. So 2 times negative 2 is negative 4. Multiplied by negative 3 is 12. So 6 divided by 12 is equal to a. So that means that a is equal to 1/2. So that tells me my function now is this. F of x is equal to 1/2 x plus 2, x minus 2, x minus 3. And that is the polynomial that matches that graph. You all ready to try one? Okay. Now, mine won't be pretty. So I'm just going to draw it down here and not prettiness, not like that, so pretty. And I'm going to give you this point, which is, we'll go with it 0, 7. Okay, now see if you can find the polynomial that matches that. So my zeros are negative 3, 1, and 5. What are my factors from those zeros?
X plus 3, x minus 1, and x minus 5.
How is it behaving when x equals negative 3?
Well, it's going back up, so it would be squared.
Yep, so that's squared. What about at 1?
It's going down like a line.
Okay. What about at 5?
It's turning around, so that would be squared, right?
Yep. So this is what we have so far. F of x is equal to a
Okay.
multiplied by all of that. Now what do we do?
Put the 7 in.
Put the 7 in. Well, right away I put that 7. All sassafras.
F of x, and then you put 0 equal. X
So I'm going to have
plus
7 is equal to, because this is what I'm going to use, this is f of x evaluated at 0. So 7 is equal to a, and then I put 0 in, plus 3 squared, then 0 minus 1 raised to the 1, and then 0 minus 5 squared. Now what? Now what do I do?
You solve.
Okay.
Algebra.
Oh, that old algebra thing.
Math.
We're going to math it out. So a, and then don't forget to take the 3 and square it. When I take 3 and square it, what do I get?
9.
And then negative 1 to the 1 is just negative 1. And then when I take -5 and square it, what do I get? 25, which is funnier than 24.
Yeah, he's cool.
SpongeBob. SpongeBob. Oh.
He's not cool.
My
Okay.
parents wouldn't let me watch it, they thought it was stupid.
Yeah, my parents did too, but I watched it in secret.
Oh, it was every morning. I watched it with my youngest son. He grew up with SpongeBob. We'd watch SpongeBob, and then I'd walk him to school, then I'd go to work. That was my morning. So when we had this contest on my radio station, I was listening to see who could sing the entire theme song. So I call up because I knew it.
Yeah.
I'm like, lives in a pineapple under.
Yeah.
Anyways, I won free tickets to a concert.
Really? What concert?
Who was coming in? It was like, so this was 20 odd years ago. So I think, who came there? I gave the tickets away because it wasn't a band I normally would watch, and I'm not going to stand in a concert for that. But it was, God, I can't remember. I gave the tickets away. Yeah, I don't go to concert. Too many people. Anyways, go back to this. Now what? What do we do now?
So 9 multiplied by -1 is -9. Multiplied by 25 is -225.
Now what?
How you divide -225 by 7. Or 7 by negative. You know what?
Okay, so once we've done that, I now know what my polynomial is. My polynomial is f of x is equal to -7 over 225, or -7 225. And then it's going to be x plus 3 squared, x minus 1, x minus 5, the quantity squared. And that is my polynomial. Now let's just stop and think about this. My leading coefficient is negative. What is the degree of my polynomial here? It's 5. So I know that n is 5. My leading coefficient is less than 0. Does this graph behave the way I expect it to based on the degree of my polynomial and the leading coefficient?
Yes.
Yes. So I know that this is probably the polynomial of least degree. I say least degree because right now they look like quadratics at 3 and -3 and 5, but they could have been quartics. It could have been a power of 4.
If the leading coefficient was a positive or above 0, would it basically the same thing just switch?
Yeah, it would have done this thing. So it would have reflected over the x-axis. So if my leading coefficient was positive, then it still would have had the same behavior of the graph. It would still come up, bounce, and this time you'd go through -7. You'd still pass, you'd bounce, and go up. So if the leading coefficient was positive 7 over 225, then that's what that graph would look like, but now we're going to pass through 0, -7. So it's just a reflection across the y-axis, or the x-axis. How was that? Cool, because that's what we're going to be doing in class today.